Good evening, ladies and gents. I'm recording this from Scotland, from the Highlands, and today's or this evening's worksheet will be about the solutions to worksheet number 1. It will be a short lecture since I want to go on my hike. So let's get started. So as you can see, we have 3 problems on the worksheet. And I'm going to first start working on problem 1, find the area bounded by the curves, x plus y equals 0, and the curve x equals y squared plus 3y. And so let me pull up the whiteboard, and we will get started. Okay, so I have the whiteboard, and so let me write down the problem. So what are the 2 curves? They're x plus y equals 0 is the same as saying x equals minus y. I'm going to write it this way, as you'll see in a moment, and x equals y squared plus 3y. And it's convenient to rewrite this as y times y plus 3 in order to graph it. The first curve is a straight line. Let me draw some axes of slope minus 1. It's the same as y equals minus x. And the other curve is a parabola, and we can determine where that parabola crosses the x-axis by setting y times y plus 3 equal to 0. We see where it crosses the x-axis, and it crosses the x-axis in exactly 2 places, at the origin at y equals minus 3. And this is a parabola. It looks like x equals y squared, except that it's moved over, and it's shaped like this. Goes through x equals minus 3. Good enough. Okay, so this is shaded region we're trying to compute the area of. I'm shading it in. And in order to figure out what the limits of integration are going to be, we first have the origin here as one of the intersection points. And the other intersection point is 3 comma minus 3, because y is minus 3. Okay, so now if we take a strip, we're going to integrate with respect to y here. It's easier to do the problem that way, of thickness delta y. Then we're going to compute the integral from, oops, I think I made a mistake here. This is not correct. Let me erase. This is not the intersection point. In order to compute the intersection point, the other intersection point, we have to set the 2 curves equal. That was a mistake, a big mistake. So let us compute that. So where do these 2 curves intersect? Well, they intersect when x equals minus y is equal to x equals y squared plus 3y. In other words, when minus y equals y squared plus 3y. And that's the same as y squared plus 4y equals 0. And that's the same as y times y plus 4 equals 0. This gives you y equals 0 and y equals minus 4. But if y is 0, then x is 0, because it's on this straight line. And if y is minus 4, x is 4. So this point is actually 4 minus 4. So I've corrected my mistake. So now the limits of integration are respect to y. Y is going from minus 4 up to 0. And then what is the length of this horizontal strip that I drew? Well, it's the difference between x equals minus y and x equals y times y squared plus 3y. So we're integrating that difference with respect to y, so that's the area. I'll call it A. And this becomes the integral from minus 4 to 0 of what? Of negative y squared minus 4y dy, and that is the same thing as negative y cubed over 3, that's the antiderivative, minus 2y squared from minus 4 to 0. And what do we get when we evaluate it at 0? We get 0 when we evaluate it at 0, and when we evaluate it at minus 4, we get negative. 4 cubed is 64 over 3 minus 2 times 16. So that is of course 32 over 3. And that is the solution. Okay, so that is problem number 1. Let's go to problem number 2. So what is problem number 2? Let's go back to the page. Find the volume of the solid obtained by rotating the curves y equals 2x and y equals x squared about the x-axis. So let me return to the whiteboard. Okay, so let's get started. So it's y equals 2x and y equals x squared. That's going to bound a region, and it's around the x-axis. Bad drawing. Let me redraw that axis. Okay, so how does that work? Well, y equals 2x is a line of slope 2, so it roughly looks like this. And y equals x squared is a parabola that looks like that. And we're taking this bounded region, I'm not going to shade it in, and rotating it around the x-axis to form a solid. And now let's take a little strip of thickness delta y, and let's rotate it, and you get a washer shape. Okay, so we're going to get, we have the big radius of the washer, and we have the little radius of the washer. And we're going to get pi r squared, big R squared minus pi little r squared times the thickness is going to be the volume of that washer. So this is going to help us remember what to do in the integrand. So big R is given by the distance from the straight line to the x-axis, and that's 2x. So this is delta. This is not delta y, this is delta x. Ha ha. I'm really blowing this. This is delta x. Delta x. Okay, so it's big R is given by 2x, and little r is given by x squared. So we're going to get pi times 2x quantity squared minus pi times x squared squared, which is pi, I'll factor out a pi, times 4x squared minus x to the 4th, if I've done this correctly. Okay, so we're going to integrate now, which means we cover it with these strips, and we're going to integrate. We have to figure out these intersection points, because that's going to tell us where x is going from. So it's going from 0, 0, and now what is this intersection point? It's where 2x equals x squared. Well, that's when x equals 2, so it's 2, 4. So x is going from 0 to 2 in this picture, and it's pi. I'll bring the pi through the integrand, 4x squared minus x to the 4th dx. And that's, what is that? That's pi times 4/3 x cubed minus x to the 5th over 5 from 0 to 2. And if we stick in 0, the evaluation at 0 gives us nothing interesting. So we just have to stick in 2. And when we stick in 2, we get pi times 4/3. 2 cubed is 8 minus 32. That's 2 to the 5th over 5. And if you do the arithmetic, you should get 64 pi over 5. 64 pi over 15. Okay, very good. Okay, so we've done problems 1 and 2, and now let's go to problem 3. Find the volume of the solid obtained by rotating the curves y equals x squared and x equals y squared about the line y equals 1. Somehow I suspect I already did this problem in one of the other lectures, but I'll do it again. It seems very familiar to me. Okay, so let's go through that on the whiteboard. Okay, so what do we got? So we have y equals x squared, which is a parabola. And we have x equals y squared, which is also a parabola. And we're supposed to compute the volume of what you get by taking the shaded region and rotating it around the line y equals 1. Here's that line. We're going to rotate it around that line y equals 1. So let me blow up the picture over here. So put a dotted line y equals 1, and then we have here's the y-axis coming in, and I'm just redrawing the picture bigger. Okay, so let's take a little, I think it's easier since we're rotating it around the line y equals 1 to take a strip like this, and the thickness of the strip will be delta x. So we're going to integrate, that tells us they're going to be integrating with respect to x. And when we rotate it around the y equals 1, we're going to get a washer. So let me figure out the little radius and the big radius, big R and little r of this washer. So what is big R? That's the distance from y equals 1 to y equals x squared. And if I remember correctly, and that's 1 minus x squared, right? And little r is the distance from the dotted line, y equals 1, to this curve here, and that's x equals y squared. But that's the same as saying y equals the square root of x in the first quadrant. So that's going to be 1 minus the square root of x. And so the volume is going to be the integral. Oh, so where do these meet up at 1, 1, and also at 0, 0. So we're going to be integrating x from 0 to 1. And then we're going to put a pi. I'll put the pi through the integrand, and it's big R squared minus little r squared. So 1 minus x squared minus 1 minus the square root of x, quantity squared dx. Do feel like I've done this problem already. Okay, so what do you get? We integrate by first expanding 1 minus 2x squared plus x to the 4th minus 1 minus twice square root of x plus x dx. And we can simplify it even further. The ones cancel. So we're going to get x to the 4th minus 2x squared minus x plus twice the square root of x dx. I did this in the descending powers of x. Okay, and if we integrate, we get pi times x to the 5th over 5 minus 2/3 x cubed minus x squared over 2 plus 2, so it's going to be 4/3 x to the 3/2, right? Because the derivative of that is 2x squared of x. And then that's going to be integrated from 0 to 1. And then we sticking in 0 doesn't do anything. We're going to get pi times 1/5 minus 2/3 minus 1/2 plus 4/3. And if you do the arithmetic, you will get 41 pi over 30 as the answer to the third problem on the worksheet. Okay, so there you have it. I'm going to go take my hike now, my evening hike. And then I'm going to eat some haggis, Haggis. You can look that up online, what haggis is. And I'm not really going to eat it. It's disgusting. Take care. Bye.